I have talked about you need to define the projections of the map in order to use the cartopy functions, right? So here you can see it supports many different projections. You can see from this. You can see from this website. Well, it has so many projections cartopy supports, and you may want to find your own projections when you need to plot anything. So here I just list a few examples. Basically, you can see just add a bunch of subplots in the same figure. And each subplot, like here is the first subplot. I generate access object for this index, like the first subplot here. And then I just use the projection here. And then this will be this projection. And then here I also used another projection for another subplot. So, well, you can see the lines are pretty repetitive here because, yeah, they are pretty much the same. So we can always use some shorter codes to do repetitive tasks. For example, here I define a projection list. This is a list of the projections I want to plot. And then I use the enumerate function to loop over all these components. Now, you can see this generates the same output. Well, you may want to study enumerate by yourself, and you may make use of it when you do some repetitive tasks. So here, I generated a bunch of maps. Now I want to add some data on the maps so that it can generate plots like weather map or something like weather maps. So in order to plot the data on these maps, you need a parameter called transform. So let's just showcase this data first. Let's open this data set, ERA5 sample 2. And then we just assign the necessary the data arrays to these variables. So you can see I take out the wind components from the 200 hectopascal level, and these are mean sea level pressure and 2-meter temperature. And I also make the XY, the longitude and latitude mesh, so that we can use the coordinate information to plot the data in the matplotlib function. Here I show you an example to plot the quiver of the 200 hectopascal wind. So these are actually the same function from the same line of codes from tutorial 1. Yeah, I just make a skip object to skip the data that we want to plot, and then add the access object here. We define the coastlines, we define the grid lines here, and this is the plots that outputs here. You can see some of the map features in the background of the plot. But if we want to change the projection, like for example, if we want to change the map projection to orthographic, for example, if you just, I need to also copy this. Like if you copy this whole thing to here, and then you just run it, it will not change the projection for you. You need to define a transform parameter here. And then you need to define what is the projection of the data, because data have its own projection. The projection of this data is a latitude longitude system separated by constant degrees. So this kind of projection is called this one. Then you just need to define the projection of the data in this parameter, and then create a map. And then create a map with your designed map projection in this variable. You click it, run it, then you it will transform your data into the designed projection that you want. And in this quiver plot, you can see that like these quivers, these arrows near the pole are really distorted and they are very densely packed together. In this case, there is a function in the dot quiver to help you redistribute the arrows in this plot. So I also add another parameter here, which is called regrid shape. Yeah, I think it's called regrid shape. Yeah, regrid shape. And then maybe 20 here, you may want to see the documentation of this parameter to see what it means. So here you can see, okay, the arrows are distributed equally within this map projection. So